I was supposed to record this. Okay, so I forgot to record this until now, so I'm just going to give you some highlights and some things that I was mad about on your quiz. First of all, a lot of people missed letter B. It is not possible. There is no multiplying or dividing rule. For number 2, average value, yes, we did do this. Average value formula is right here. So I took this interval, 2 to 4, and I had the integral, or 1 over 4 minus 2 times the integral from 2 to 4. Then we evaluate an integral. To evaluate an integral, we take the antiderivative and then evaluate top minus bottom. Notice the notation here. That was some of the things that I was really upset about. This integral sign is no longer here once you take the antiderivative. The bar for our boundaries goes at the end. Then I kept this 1/2, and then I evaluated top minus bottom. Do you see these parentheses? They are huge and critical to doing this problem correctly because we end up having to distribute this negative. And then finally on number 3, it said to find the total area. So one of the first things I was looking for was this graph. And then because this area is below the x-axis, I flipped it. Instead of doing -1 to 1, we do 1 to -1 for our integral. This area is above the x-axis, so it stays the integral from 1 to 2. Again, to evaluate an integral, take the antiderivative and evaluate top minus bottom. Notice we have top minus bottom in parentheses plus top minus bottom. Be very careful with that. Also, we did this, most of you guys were really good on these dy dx ones, so I'm not going to stress about that. It's just some of you forgot to multiply by the derivative of the boundaries. So I'll just show you those real quick. If you have any questions, you come see me. Okay, number 7. Y equals, we're given our function. We have the interval from -2 to 2. I gave you your calculator. Stinkin' learn how to read. Remember that learning how to think thing? That's coming into play here too. So using the fundamental theorem of calculus part 2, integrate the function over the interval. Show your integral and all the work that leads to your answer. So integrate just means to take the integral over the interval. So I'm showing this. I'm setting up my integral. Don't forget dx at the end. Notation, I did not take points off, but I will. Then how do we evaluate an integral? We take the antiderivative. So you're showing me this. -1/4 x to the 4th minus 2/3 x cubed plus 5/2 x squared plus 6x from -2 to 2. You're not done showing work. Top. So I'm substituting the top minus bottom. If I were doing this test and I was told to show all the work, I would show this work. But I had the calculator, right? I let you have the calculator. So I wouldn't do any more work than that. You showed me your integral. You showed me your antiderivative. You showed me that you knew to do top minus bottom. So then you give me your answer straight from the calculator, which I believe is 40/3. Letter B, make a sketch. Almost all of you did this right. Somebody forgot to shade. You, again, read the dang directions. Letter C says, find the total area of the region between the graph and the x-axis. Set up the problem using your fundamental theorem of calculus part 2, but you can use your calculator to evaluate. Since this is asking for total area again, we already had the shaded or the graph above, so total area is where we take anything that's below the x-axis and we use an integral, but we flip the boundaries. So I believe it was -1 to 2. So the integral from -1 to 2 of our function, I forget what it is, plus, I flip those boundaries, right? Then from -1 to +2, it's normal. So I keep it -1 to 2. Don't forget your dx, so your function goes here. That's all you had to show me. Then you had your calculator to evaluate, which I'm pretty sure it's 109/6. Any questions on that page? Don't forget this equation would have to go in there, right? Just skipping around a little bit. Again, use the fundamental theorem of calculus, part 2, to evaluate the integrals, then use your calculator to support your computation. So I gave you the calculator. I still wanted you to do all of this work, but I wanted you to check your answer with the calculator. So how do we evaluate an integral? We take the antiderivative. The antiderivative of 1, x, the antiderivative of cosine, positive sign. I had a bunch of minus signs there which mess people up, so be very careful. Should be positive sign. Then notice my bar, 0 to pi halves, no integral sign, right? We're going to get this if I have to break fingers or something. Then top minus bottom. And sine of pi halves, I saw a bunch of charts, which is awesome. Sine of pi halves is 1, sine of 0 is 0, so it's just pi halves plus 1. And your calculator probably gives you that exact answer if you put it back into exact mode. Letter B, same thing. We find the antiderivative, so 1/3 x cubed plus 3/2 x squared minus 7x, and we evaluate from -2 to 1. So then we do top minus bottom. And you had your stinking calculator, like, I know this was fractions and stuff and I wanted to see your answers, but you had your calculator. I think -22.5.
Yeah.
Questions, comments, concerns? About that? Anything so far? Okay, now, this one, I don't want to hear any whining, and I don't want to hear that we didn't do this, because we certainly did. The graph of the function f, remember this thinking thing, right? And I think I warned you the other day, we're to the point now where more of this stuff is going to start showing up because we can start relating things. There's things in this problem that went all the way back to chapter 3, to the beginning of the course. So we can start doing that. So you're going to see more and more of this stuff. The graph of the function f, consisting of 3 line segments, that's amazing that they're telling us that, right? That's important information, is given above. So this is a graph of f. Let g of x equal the integral from 1 to x of f of t dt. There is a critical, so important thing that you have to realize as soon as you see something like this. What in the world are they telling us? What is so critical about that g of x equals the integral of f? What's the relationship between g and f? The derivative of g is f, right? That's huge. So, since this is a graph of f, this really means it's a graph of g prime. This is a derivative graph. What's the other thing I've told you to do as soon as you realize you have a derivative graph? Make a number line out of the graph. We have -2 to +4 for our boundaries, closed endpoints, right? One critical value at 3. You with me on where I'm getting all this? And it's plus, minus. What does that tell you? 3 is a max. The endpoints are mins. We didn't even read the problems yet. We got all of this information just by the information that was given at the beginning, right? Anything there that didn't make sense? Letter A, compute g of 4 and g of -2. Now, I get people that get stressed out about the word compute. Just means to find, right? Get the stinking answer. So, compute g of 4. G of x equals this integral. So g of 4 equals the integral, I think it's from 1 to 4, of f of t dt. We need to evaluate that integral. How do we evaluate integrals? Well, normally we take the antiderivative and do top minus bottom, but we cannot. We don't have a function here at all. So how can I use what's given to find the integral from 1 to 4? Integrals, in its most basic form, is area under the curve. Just like derivatives are basically slope, but so much more, right? Integrals are basically area under the curve, but so much more. So I'm finding this shaded region. Yes? So I made this a square, a triangle, a triangle, a triangle. Anything that's below the x-axis is negative. So first I had my rectangle or my square. Plus I had the big triangle, which was a base of 1 and I think a height of 3. Plus the little triangle, which a height of 1 and a base of 1. Subtract the little triangle, 1 times 1. So this came out to be 1 plus 3 halves. These canceled, so I got 5 over 2. So g of 4 is equal to 2.5, or 5 over 2. Yes, no, maybe. G of -2 then is the integral from 1 to -2 of f of t dt. 1 to -2. There was something about that. 1 to -2. 1 to -2. It's flipped, it's backwards, it's wrong, right? It's going in reverse. So what does this mean? Even though the triangle is above the x-axis, it's going to be negative. Because we would pull out a negative here and put negative the integral from -2 to 1. Are you with me? But we can just see that in our mind. So it's a triangle. We knew these were line segments, right? Which is huge. So this is actually going to be -1/2. Base is 3. Height is 4. So -6. Am I going too fast? Do you have questions? Letter B. Find the instantaneous rate of change of G. Instantaneous rate of change. Everyone in this classroom knows what that means. Instantaneous rate means derivative. All this was asking for was G prime of 1. G prime of 1 is the same thing as f of 1. Show the people grading your test that you know the relationship between G prime and f. Are you with me? So G prime of 1 has a height, a value of 4. Done. Find the absolute minimum value of G on the closed interval from -2 to 4. Justify your answer. Okay, now, we know that 3 is not a min, right? But you have to tell them that here because they want to see that you analyzed, that you thought about x equals 3. Even though we already know it's a max, you need to make sure you say something about all the critical values. So we know the min is either going to be -2 or 4, right? The absolute min is either going to be -2 or 4. But for them grading, they need to see that you know what the heck you're talking about. So this is something like what I would say. So the absolute minimum value will occur at endpoints and critical values. I shouldn't say and. So x equals -2, 3, or 4. You with me? Then I would say something like, since g prime, which is f, make sure you show them that you know how they're related, changes from positive to negative at x equals 3, 3 is a maximum. So now, g of -2 is, we did it in part A,
No, you just went up by -6.
-6. And g of 4, these are the endpoints, right? We did this, is 5/2. So the absolute minimum value is -6 for g. Remember, a minimum value is the y value. I feel like I should say something about x equals, whoa, what happened there? X equals -2 and x equals 4 will be minimums. Like, you just want to write in words things that are going through your mind. Does that make sense? Things that we got from the number line, you need to put on paper with words. Any questions where I got all of that? Okay, letter D. The second derivative for g is not defined at 1 and 2. How many of these values are points of inflection? Well, hold on. Why is the second derivative not defined at 1 and 2? This is g prime, right?
Because it's a change in the slope.
It's a corner,
Yeah,
right? But you're right, it's a change in slope. It's a corner. Are you with me? So the second derivative of g doesn't exist at 1 and 2 is because they have corners. So are either of those points of inflection? Yes.
Yes, both of them are because.
No.
No, x equals 1 is because the slope changes.
The
Change of both.
derivative of g changes direction. The slope changes from positive to negative. Now, at 2, it's decreasing and continues decreasing, right? So, at x equals 1, there is a point of inflection since g prime, which is f, changes direction. Do you have to have that exact words? No. Something with calculus reasoning. Because g prime, which is f, changes from increasing to decreasing, whatever. Then, at x equals 2, there is not a point of inflection since g prime, which equals f, continues to decrease. It doesn't change direction. The slope changes, just not the direction. Yes, no, maybe. Now, do I expect a lot of you to get a bunch of points on those? No, I'm putting them there so we can start thinking. I know if you get 3 or 4 points, you're doing great at this point. But that doesn't mean that we shouldn't start thinking them through, right? Because they're going to show up more and more. So we're going to postpone the test until at least Monday. I have this worksheet